Hello everybody, my name is Agustin Garcia.
My name is Bishop Dan.
And today we will be demonstrating our project 2 for numerical methods. So I will be conducting the hardware portion of this experiment. This whole board, including the ultrasonic sensor, is powered by this 5 volts being emitted by the Arduino. I apologize for that. These two LEDs are both connected in series with 320 ohm resistors in total. The red LED is connected to the 5 pin, the green is connected to the 3 pin, the trigger is connected to the 6 pin, and finally the echo is connected to the 8 pin.
So this is our GUI. This first half consists of our part 1 of our GUI. Graph number 1 displays our sinusoidal waves data from using our pendulum here from the ultrasonic sensor. And graph number 2 over here displays the values of each length and the period from the G input using our G input button to calculate the periods. And these 3 buttons show the first, second, third order displaying here on the second graph.
And then this third graph here is a predicted measure values, where the user inputs the 7 different lengths that they want to use and the 7 different periods that they predict of the pendulum swing. Now I will be showing you how our pendulum project works. We will begin by showing you our predicted graph value. Here we have our 7 lengths that we will be measuring and our 7 user input prediction periods. By clicking this button, you will have the sinusoidal graph of the prediction value, and by clicking this, you will have the iteration of Euler's methods using Euler's calculation for the prediction value. Now we will begin by having this drop-down menu and clicking length 1. So right now, data is being collected, indicated by this green LED. If we give it a gentle swing, right now, raw data is being collected. This red LED will start blinking, signifying 0 crossings. So now we have our raw data being plotted here. If we click our smooth data, it will show us a smooth iteration of the data compared to our predicted value. Now, we will press this button, collect length 1 for our gravitational constant, and giving us 7.15.
After clicking our Euler's plot button, we could see that the plotter prediction is indicated by the blue line and the Euler approximation is indicated by the green line. We can better fit this by adjusting this step size value to, let's say, 0.0008 and pressing this button again, and we can see that it's better fitted. After collecting our length 1 data, which is shown in UI axis 1, we press this G input button, which brings us to this figure, and we select 2 points at any oscillation. We go back here, and it's displayed over here on period 1 for length 1.
So now that we have our 7 periods collected, we will show the first, second, and third order period for the polyfit. So here we have our first order, second order, and third order, indicated by black, blue, and green. So now once we have all of our data collected, we can save the data, indicated by this symbol right here. We can name it, number 1 for instance. So now that information is saved, we can load back that data by clicking the value and opening it up. Finally, we could erase all of the information from this GUI by simply clicking on Clear All Graphs, and thus clearing everything from the GUI.